Solar panels plus farming, agrivoltaics explained. Agrivoltaics is a cutting-edge strategy that integrates solar energy generation with agricultural activities on the same piece of land. This technique increases land utilization, improves agricultural yields, and gives farmers more revenue by incorporating solar panels into farming. Agrivoltaics provides a sustainable answer that helps the environment and agriculture at the same time when the globe faces issues with food security and renewable energy. In this video, we will highlight the key points about agrivoltaics. Number 7. Definition and concept. Agrivoltaics is a creative and diverse method that blends solar energy generation on the same land with agricultural operations in a way that works well together. With the help of this dual-use device, farmers may cultivate the land below while also using solar panels to harvest sunshine for electricity. The idea came about because there is an urgent need to enhance land efficiency in a world where population expansion, urbanization, and climate change are endangering traditional agricultural methods and reducing the amount of arable land that is accessible. Utilizing vertical space for solar panels, agrivoltaics tackles important global issues including food security and the production of renewable energy, while also optimizing land utilization. This model encourages a complete approach to land management by promoting strategies that enhance agriculture and energy production while upholding the goals of sustainable development. A shift toward integrated systems thinking, which recognizes and takes use of the interdependencies between energy generation, food production, and environmental stewardship for greater overall impact, is also represented by agrivoltaics. Number 6. Land use efficiency. One of the most appealing benefits of agrivoltaics is its efficient use of land, especially in a period where competition for natural resources is on the rise. Arable land is under increasing strain due to the growing global population and urbanization, which could result in conflicts between the production of energy and agricultural needs. Large areas of land that could be used for farming are sometimes needed for traditional solar farms, a problem that agrivoltaics successfully solves. This method allows farmers to continue farming while producing sustainable energy at the same time by permitting solar panels to be erected over crops. In addition to aiding in the preservation of priceless agricultural land, maximizing production on currently farmed land also lessens the need to destroy forests or other natural habitats in order to make room for new solar systems. Agrivoltaics is a sustainable solution that enhances food and energy security and supports responsible stewardship of natural resources in areas where space is limited or where agricultural lands are threatened by development. Furthermore, by reducing the infrastructure expenses linked to separate solar farms and agricultural operations, this effective use of land can further improve the economic viability of agrivoltaic systems. Number 5. Benefits for crop growth. Crops and solar panels can interact to create distinct microclimates that improve plant growth in a number of ways. The main advantage is that shade can assist lower soil temperatures and water evaporation rates, which are important in areas that are vulnerable to drought or excessive heat. For example, some crops, including leafy greens like spinach and kale, do better in partial shade and may produce more than they would in full sun. Additionally, during the hours of greatest sunlight, the shading effect might lessen heat stress, enabling plants to save energy for growth rather than survival. Additionally, solar panels can physically shield crops from inclement weather like hail and intense sunshine, which increases crop resilience. Studies have indicated that agricultural yields can be sustained by solar arrays, and in certain instances, they may even increase as a result of these advantageous growth circumstances. For instance, research has shown that crops produced in solar-powered greenhouses may retain more water in the soil, which is essential for growth during dry spells. In addition to increasing production, this partnership between agriculture and renewable energy fosters biodiversity by enabling a range of crops to thrive in creative environments. Number 4. Enhance energy production. Interestingly, by utilizing the cooling effects offered by surrounding plants, agrivoltaics can result in enhanced efficiency in solar energy production itself. High temperatures usually cause solar panels to overheat and lose effectiveness. However, when placed over crops, a cooling impact of the plants below helps to keep the panels cool. Transpiration, the process by which plants release moisture into the atmosphere, can considerably enhance the performance and energy production of the solar panels by generating the cooler microenvironment surrounding them. According to studies, as compared to conventional ground-mounted solar systems, this cooling effect can increase electricity generation by several percentage points. For example, studies have demonstrated that this special relationship between plants and solar technology allows agrivoltaic systems to produce up to 20% more energy than standard systems under specific situations. Moreover, without needing extra space or resources, this improved performance increases total energy production. Optimizing current agricultural lands through agrivoltaics gives a crucial opportunity for boosting clean energy supply while bolstering local economies as the need for renewable energy continues to climb internationally. Number 3. Economic advantages for farmers. Farmers can increase their financial stability and diversify their sources of revenue by implementing agrivoltaic systems. Farmers who have historically relied only on crop sales are exposed to a number of risks related to shifting consumer expectations, market volatility, and climate change. Farmers can increase their income by leasing land for solar installations or by selling excess electricity back to the grid through net metering or power purchase agreements by incorporating solar energy production into their business. In addition to reducing financial risk, this dual income approach offers opportunity for investments in new or improved farming technologies that increase sustainability and productivity. Additionally, a lot of governments provide financial aid in the form of tax credits or subsidies for renewable energy projects that encourage farmers to practice sustainably. This makes agrivoltaics even more financially viable for those looking for long-term solutions that complement their operational objectives. Farmers can navigate a more solid financial framework while dealing with an increasingly unpredictable agricultural terrain when they have both reliable crop income and earnings from renewable energy sources. Number 2. Environmental impact. Agrivoltaics' environmental advantages go much beyond only making optimal use of available land. They also provide a substantial contribution to sustainability initiatives that strive to lower greenhouse gas emissions and protect ecosystems in a variety of environments. Rather than extending into forests or natural habitats, which frequently results in habitat destruction, agrivoltaics maximizes productivity on already existing agricultural fields, protecting biodiversity and preserving ecological balance within nearby ecosystems. Integrating renewable energy output lowers carbon emissions linked with traditional energy sources by reducing dependency on fossil fuels, a major contributor to climate change. Additionally, by lowering erosion through prudent management techniques that shield the soil beneath solar panels from deterioration brought on by wind or water runoff, agrivoltaic systems can enhance soil health. This all-encompassing strategy tackles important problems like resource depletion and climate change while promoting a better environment. Agrivoltaics can also improve pollinator health by introducing diversity into agricultural landscapes, which is crucial considering the present global fall in pollinator numbers as a result of habitat loss and pesticide use. Number 1. Global applications and future potential. Agrivoltaics is becoming more and more popular around the world as a workable way to sustainably meet the growing demands for food and renewable energy in a variety of locations and climates. Globally, numerous projects are showcasing its adaptability to diverse farming methods. For example, fruit orchards in California are employing overhead solar arrays that are specifically made for dual use, preserving fruit quality during harvest seasons. Similarly, European vineyards are implementing similar tactics during grape cultivation seasons, where managing sunlight exposure according to varietal requirements for ideal growth cycles during maturation periods is crucial to harvesting grapes later in the year. Agrivoltaic systems, for instance, have been successfully incorporated into farming landscapes in countries such as South Korea, where farmers grow crops like tomatoes and generate electricity from overhead solar panels specifically designed with dual-use considerations taken into account so as not to negatively interfere with crop yields or quality standards expected by consumers purchasing locally grown products. Initiatives focusing specifically on East Africa are investigating this dual-use model as a way to improve food security while utilizing renewable energy sources in the face of ongoing challenges related to climate change resource scarcity, which disproportionately affects smallholder farmers who heavily rely on consistent access to affordable inputs needed to sustain livelihoods over time despite constant threats from the outside world. Potential applications of this novel approach, when combined with technological developments like better panel designs that maximize light capture, are expected to spread beyond traditional farming contexts and into urban agriculture settings or degraded lands in need of revitalization through sustainable practices that are specifically tailored to address the unique challenges faced by each location individually. To sum up, agrivoltaics is a revolutionary strategy that balances the production of renewable energy with agricultural output, opening the door to a more sustainable future for both industries while successfully tackling major global issues. Thanks for watching our video, and don't forget to subscribe.